Welcome to the AP Physics lecture. This is covering the second law and dynamics. First of all, we're going to talk about what an unbalanced force is. The difference between equilibrium and unbalanced force is that in equilibrium, an object acceleration is equal to 0. For an unbalanced force, the forces are not in equilibrium, therefore they're not balanced. As a result of it not being balanced, there is going to be some form of interaction. Instead, these forces are considered to be unbalanced. The fact that the forces are unbalanced, there is going to be an acceleration that results in Newton's second law. Because this is referred to this is the forces. When the forces here become unbalanced, there is an acceleration as a result. But if these balance, then the acceleration is going to be 0. Okay, if you rearrange it, it looks like F net is equal to ma. You're going to be using this a lot in the calculation, so make sure you understand this. This is Newton's second law in its classic form. The sum of all the forces is equal to the mass times acceleration. The method of solving solutions for an unbalanced force is the same thing as the equilibrium problem, except in this time when we do the solve step, we substitute in ma instead of 0 in its place because there is going to be an acceleration. Please understand that the mass is the mass of the system, and the A can be seen as the acceleration of the system. Okay, you can do it individually, but it's best to think about that as the system in of itself. So here's an example. A 10-gram mass is pulled along a frictionless surface by a rope exerted by 20 newtons force. Determine the magnitude of the acceleration. So we saw that this object is moving in the x direction, so we say the summation of the forces of x is equal to ma. The object is not going up or down, so we say in the y direction it's at equilibrium. The summation of the forces in the y direction equals to 0. The diagram looks like this. There is actually an issue with this image. Okay? The fact that the object is accelerating to the right, we have to make sure we draw the length of the T that's pulling it to the right a little bit longer. Okay? The length of the normal force has to be equal to the length of the friction force. We see that the x and the y direction are mathematically independent, so we can solve for both. Either or both. Here's the summation of my forces. The only force in my x direction is just T, which is the tension force that's being pulled on the rope. Substitute. This goes to ma because again there's an unbalanced force, and that is because there is an acceleration. Divide m to both sides, you get a equals to t divided by m. This is 2.0 meters per second squared. This is the acceleration of the system. And the system is just a block. Next, we look at a 10 kilogram mass is pulling upwards by a 122 Newton force. What is the acceleration of the box? We first assess this by saying that in the y direction, the summation of the forces in the y direction equals to mass times acceleration, because the object is moving up and accelerating up. Then we saw that there's no movement in the x direction, so we would say it's in equilibrium in the x direction. Summation of the forces in the x direction equals to 0. Here's the diagram. There's a problem with this diagram. Here it shows that the tension force equals to Fg. This is wrong. It has to look something like this. the t has to be longer than the FG. Why? Because the object is moving up. If you draw it like this, this shows that the object is at equilibrium here, which is wrong if they're equal. So make sure you draw the vector of the t longer than the vector of the force of gravity, because the object is accelerating upwards. If we do the summation of my forces, summation of my forces in the y direction equals to tension minus Fg, because tension is positive, Fg is going to be minus, because anything going up is positive and anything going down is negative. We plug it in. I got my summation of my forces is in the y direction equals to 20 newtons. Now I plug it in because I'm trying to solve for the A. Okay. This is going to be equal to mass times acceleration is equals to 20 newtons. Now just divide this by the mass. I saw that my A is equal to 2 meters per second squared. Okay. So this is the acceleration in the y direction, which is also the system. We saw in the last problem, it was horizontal. Here we see it vertically. Next, we're going to do it on a ramp. Before that, you want to take a look at its vector component. If the force is diagonal here, to get the horizontal component, we multiply by the cosine theta part. Exactly like this example. They had 50, so we're going to multiply 50 by the cosine 37 degrees. So this is the cosine part. And this is the vertical part, which is going to be the sine part. That makes sense because theta is right here. Make sure you're able to break things down in its horizontal component and its vertical component form. A 10 kilogram mass initially at rest is pulled by a rope with 20 newtons tension directly at 37 degrees. We saw that there is a theta here, and that equals to 37 degrees. So first, we assess this by looking at its direction. We saw that the object is moving in the x direction. It's accelerating, so we said summation of the forces x is equal to ma. The object is stationary in the y direction. It's in equilibrium, so we say the summation of the forces in the y direction equals to 0. If we draw the diagram, it looks something like this. The normal force balances out with the force of gravity, and we have the tension force being pulled. This is the diagram. This is the free body diagram. The AP exam on the free response will always ask you to draw the FPB. They never ask you to draw the components, but you will need to draw the components and label it here to help you out. So T can be broken down by its horizontal part, which is TX cosine theta. And the ty is going to be tx is equal to t in the x direction is t times cosine theta. Ty is going to be t times sine theta, right? Anything going up is positive, anything going down is negative. Now we do summation of the forces. The forces in the y direction are your n, which is going up, plus your ty. So they just made this f. This should be t. Okay, ty minus tg. Yep. N plus ty minus tg. No, sorry. Fg. Yeah. So the summation of my forces in the y direction is the normal force, which is up, plus the tension force y, which is up, minus Fg, which is pulling it down. Now you can substitute. Okay, this was the tension force, right? We call that tension, yeah. Tension. So N, so it equals to N Ty. Remember, we labeled that as T sine theta, and Fg just breaks down. F force of gravity is just mg. Again, the object is in equilibrium in the y direction. That's why we substitute in 0. Here's some algebra. All they did here is they add mg and subtract fg to the other side. So they add mg here to cancel it. Then they have to subtract t sine theta here, and they subtract t sine theta here. Okay, that's how they got here. So this should be n is equal to mg t sine theta. Plugging it in, you should still get the same answer here. M is 10, G 9.8, the tension force 20, and the sine of 37 equals to 86. The object is the normal force here is 86 newtons. Next, here you have a problem, the same problem, but now they ask you to find the acceleration. So the assess is the same part. The object is accelerating in the x direction, but is in equilibrium in the y direction. Here's the diagram, and we broke this up again. Tx is equal to t cosine theta. Ty is t sine theta. The summation of my forces in my x direction is just t of x. The reason why is because we're looking for the acceleration. Okay, so fx is going to be equal to a, tx is going to be t cosine theta. We saw that right here. Divide by m to both sides. Divide m to both sides. You get a equals to t cosine theta. Divide by m. Plug in the values. You get a equals to 1.6 meters per second squared. You have to see the object in two ways. The normal force is calculated by looking at the y direction. And here the acceleration is in the x direction. So make sure you're looking at the right axes. Practice 2. I would like you to take a look here. A car of mass m is on an icy drive road, inclined at angle theta equals to 20 degrees. Determine the acceleration of this car. Here, you want to assess this. This object is moving in the x direction. And what do I mean by the x direction is I mean down this way. That is going to be my x direction. And it is not moving up or down, right? So it is equilibrium in the y direction. Okay, my diagram should look something like this. My free body diagram. Here's the object, force. Normal force looks like this, and force of gravity looks like this. If I break this down into its vector components, normal force here, force of gravity down here. Let me grab a different color so when I break up the forces. So the vertical part here is going to be Fg sine theta. And this is going to be, wait, is that correct? No, that's wrong. So this is not, so because this is theta, so this is going to be cosine theta because it's adjacent. Its opposite is Fg sine theta. Good. Now let's do the summation. Oh, we got that there. Perfect. Good. So summation of my forces. In the x direction, it is just mg sine theta, fg sine theta, okay? And in my y direction, it is, my y direction was my normal force, which is going up. Then we subtract that by the mg cosine theta. And it's a subtraction because it's going down. Plug it into the equation. Here I'm looking for the acceleration, so I only care about the x part. The summation of my forces in the x direction is mg sine theta, so I plug that in, equals to mass times acceleration. The masses cancel out, so acceleration is 9.8 times sine 20 degrees. I would say that acceleration is equal to 3.35 meters per second squared. Now let's do an argumentation question. Kevin says pulling on a block with a rope at a 45 degree is easier than pulling it completely horizontal. By easier, Kevin says that the tension force he feels is less than when he pulls at 45 degrees. Argue if he's correct or incorrect. And again, this is on a frictionless surface. So there's 3 parts: claim, evidence, and reason. Your claim is your answer, just you answering the question. Evidence is the math part. The reason are your words. Try this. So I would say first, my claim is he is correct. My math is going to be me setting up the Newton's second law. So summation of the forces in the x direction equals mass times acceleration. The question looks for tension, so I'm going to solve for t. Divide cosine theta over, so I get to solve for t. Again, the situation is describing tension. That's the reason why I solve for tension, so I could talk about it. Now I see it in terms of a fraction, so I can just describe it. Since cosine theta is in the denominator, I would say that the tension force has an inverse proportional relationship with cosine theta. That means if one object goes, so that means as if tension goes up, then cosine theta goes down. Or if t goes down, then cosine theta goes up. So here I would say, as cosine theta, as tension will decrease, right here, tension will decrease as cosine theta increase, because they have an inverse relationship. Cosine will increase when cosine theta approaches 1. And that is only happens when theta approaches 0 degrees. Okay? There you go. Those are all your solutions.